This is Algebra 2 Homework 1-5. Let's jump in. In order to undo our absolute value, normally you drop this and turn it into two separate equations, but the problem is anytime you have the absolute value, you have to have a positive value. So this is a negative value, meaning that the answer for the first one is no solutions. And I can check the backside of our answers. No solution, good. I can highlight this one in green. Come to my highlighting tool, highlight in green. All right, and number 2, this one is equal to a positive, so I'm going to undo the absolute value by turning this into two separate equations. One of them is p equals positive 2, the other one is p is equal to negative 2. And those are the only two possible answers, and I think that's it. 2 and negative 2, 2 and negative 2. We got it. Does the order matter? No. They're just answers in no order at all. So I got that one right, highlight it in green. All right, and number 3, I need to isolate the absolute value first. So I need to undo this pesky divided by 2. The undoing of divided by 2 is multiplying by 2. Multiply this side by 2, multiply this side by 2. 2 and 2 cross cancel, leaving me with absolute value of x isolated, and that's going to be equal to 0 times 2, which is 0. Now I can separate this into two different equations, but it's a little bit of a silly question because x is equal to 0 is the same thing as x is equal to negative 0. So I really can just cross this one off and say, my answer is just x is equal to 0. Let's check. Number 3, x equals 0, x equals 0. I'm getting these right. So let's go ahead and highlight this one in green. All right, number 3, I need to isolate the absolute value, so I need to get rid of the negative 3 and the negative 5. Remember, the way that we undo things is with PEMDAS. Please excuse my dear Aunt Sally. Whenever we simplify, we go from the top to the bottom. But we're not simplifying now, we're solving. Solving, we go from the bottom to the top. That's how we solve. We undo PEMDAS. So first, I check, is there any addition or subtraction I can undo? I can do minus 5 and undo that by adding a 5. So I'm going to do that first. Add 5 to both sides, add 5 to both sides. When I do that, you're gone. I'm left with negative 3 times the absolute value of x, and absolute value is equal to negative 24. From there, I can now get rid of this multiply by negative 3, and I can divide both sides by negative 3. Divide by negative 3, divide by negative 3. And now x is equal to a negative divided by negative is a positive. 24 divided by 3 is an 8. And don't forget your absolute value sign like I just did. Once we have that, we need to undo the absolute value sign by splitting it into two separate equations. One of them is x is equal to 8. The other one is x is equal to negative 8. I should have an equal to sign in there somewhere. X equals negative 8. Those are my two answers. Let's check. 8 and negative 8 for number 4. 8 and negative 8 for number 4. I got that one correct, which means I'm going to be highlighting in green. All right, then I move to number 5. First, I need to isolate the absolute value, and you can see the absolute value has been isolated. So now I can split it into two separate equations. The first equation is you keep the inside, n plus 4, and then you change the outside, negative 5. The next equation is going to be keep the inside, n plus 4, change the outside. Well, this one, you still say same outside. You need both a negative and a positive version of the outside, unless the outside was negative, in which case the answer is no solutions. Each of these is going to be solved the exact same way. Subtract 4 from either side, subtract 4 from either side, and you're going to get n is equal to negative 9 for one of the answers, and n is equal to 1 for the other answer. So let's check. Negative 9 and 1 for number 5. Number 5, negative 9 and 1 in a different order, but it doesn't matter. I got the correct answer. I'm going to highlight this one in green. And number 6, I need to undo this pesky divided by 8 by multiplying both sides by 8. So I'm going to multiply the left side by 8 and the right side by 8. 8 and 8 will cross cancel, leaving me with just the absolute value of negative 9 plus k. And absolute value is equal to 3 times 8, which is 24. Now I have the absolute value isolated. It's time to separate this into two separate equations. The first equation is negative 9 plus k, and that's going to be equal to the normal 24. And then the next equation is going to be negative 9 plus k. You don't change anything on the inside of the absolute value. You only change the outside, and it's going to be a negative 24. These two separate equations are going to be solved the exact same way. You're just going to add 9 to both sides. Add 9, add 9, add 9, add 9. Those 9s are gone, leaving you with k is equal to 33 in the first case, and k is equal to negative 25 in the second case. So let's go ahead and check. 33 and negative 25. 33 and, oh, I got negative 15. I've made a mistake. Let's go ahead and find my mistake. I don't know how I got negative 25. I was going too fast. That was my mistake. But I can come down here and change this to a 15. I'll highlight that one purple. I did make a mistake. And if you caught that before I did, you can log the extra credit. If you caught it after I did, you don't get any extra credit. So I'm going to go ahead and say to myself, I got that number right there wrong. Notice how specific I'm highlighting. I don't highlight the whole thing. I just highlight only the one spot that I made a mistake in. All right, number 7, again, I'm trying to isolate the absolute value, which means I need to get rid of the 4 and I need to get rid of the 2. Which one do I get rid of? 4, because it's on the lowest rung of PEMDAS. It's addition. So I'm going to undo 4 by subtracting 4 on both sides of my equation. When I do that, I'm left with 2 times the absolute value of x divided by 9, and the absolute value is equal to 2. From there, I need to undo the 2 by dividing both sides by 2. Dividing the left by 2, dividing the right by 2. The 2 and 2 will cross cancel, leaving me with just the absolute value of x over 9, and absolute value. Make that a little bit longer so you know it's an absolute value, not a 1. This is going to be equal to 2 divided by 2 is 1. And then from there, you're going to drop the absolute value symbol and separate this into 2 different equations. The first equation is x over 9 is equal to 1. The second equation is x over 9 is equal to the other version, -1. Each of these can be solved in the exact same way. You multiply by 9 to get rid of the 9. You multiply by 9 to get rid of the 9. If you do it on the left, you also do it to the right, and you get your 2 different answers. X is equal to 9, and x is equal to -9. Final answer, box 9 and -9 for number 7, 9 and -9 for number 7. I got that one right. I can highlight this one in green. That's not green, that's purple. Green is this one. There we go. In number 8, the absolute value sign has already been isolated, which means I'm ready to separate this into 2 different problems. The first problem will keep the inside -4 plus 6x, and I change the outside eventually. I'm going to keep it positive for now. And then the second equation, I will keep the inside -4 plus 6x, and now this time I will change it to -22. You only change the outside of the absolute value. From here, I can solve each of these in the exact same way. I'm going to add 4 to both sides. Plus 4, plus 4, plus 4, plus 4. When I do that, the 4's are gone, and I get 6x is equal to, in the first case, 26, and 6x in the second case is going to be equal to -18. From there, I'm going to divide both sides by 6, both sides by 6, both sides by 6, both sides by 6, and you're gone, leaving me with x is equal to 26 over 6, which I can reduce because I can divide both top and bottom by 2, and it's going to be 13 over 3. In the second case, I can also divide both top and bottom by 6, and that's what I'm already doing. So -18 divided by 6 is a -3. Don't forget your negative. So this is going to be -3. Let's check. 13 thirds and -3. 13 thirds and -3, please. 13 thirds and -3 for number 8 is indeed correct. So I'm going to come back over here, and I'm going to highlight this one in green. I should have boxed my work, which I'll do right now. Keep boxing your work, and also highlight this one in green. That in green too. All right. Number 9, I need to isolate the absolute value. So that's the absolute value. Get rid of this multiply by -2, and I'm going to divide both the left side by -2 and the right side by -2. When I do that, this is gone, and I'm left with the absolute value of 3 plus 9v, and absolute value is equal to negative divided by negative is a positive, and this is a positive 3. From here, I have the absolute value that I need to undo, which means I'm going to separate this into 2 different equations. The first equation is 3 plus 9v. The second, is equal to 3, sorry about that. And the second equation is going to be 3 plus 9v. Again, keep the insides and change the outside. Is going to be -3. And I'm going to solve each of these the exact same way. I'm going to subtract 3, subtract 3, subtract 3, subtract 3. Our new equation on the left, you're gone, is going to be 9v is equal to 0. Our equation on the right is going to be 9v is equal to -6. And again, you're going to do these the exact same way. Divide by 9, divide by 9, divide by 9, divide by 9, and you get the 9's gone, 9's gone. V is equal to 0 in one of the cases, and V is equal to, I can reduce this fraction by dividing the top and bottom by 3, and that's going to be -2 thirds, -2 over 3. I will box my work, and hopefully I will check my answer and get it correct. 0 and -2 thirds, 0 and -2 thirds is indeed correct, which means I get to highlight this answer in green. Green, and green. All right, and number 10, I need to isolate the absolute value symbol, which means I need to get rid of the 4, get rid of the 6. Which one do I get rid of first? 6, because I can get rid of it using subtraction, which is the lowest rung of PEMDAS. So I'm going to go ahead and subtract 6, and I get 4 times the absolute value of 4n minus 7, and the absolute value is equal to 52. From there, now I can get rid of the 4 by dividing both sides by 4, dividing both sides by 4. Just as a reminder, I didn't say it in the previous problems, but I should say it now. You can never distribute into an absolute value symbol. The only way to undo things is to use division. There is no distribution. All right, when I divide by 4, the 4 and 4 are cross-canceled, leaving me with just the absolute value of 4n minus 7, and the absolute value is equal to, what is that going to be? 4 times 3 is 12, so it's going to be 13. From here, I'm going to separate this into 2 different equations. The first equation is going to be 4n minus 7. You keep the inside and keep the outside. The second equation, you're going to keep the inside, 4n minus 7, but you're going to change the outside to -13. You take the opposite. Each of these are solved in the exact same way. First, I'm going to add 7, add 7, add 7, add 7. 4n is equal to 20 in the first equation, and 4n is equal to negative, was that going to be 6 in the second case. Then I'm going to divide each of them by 4, each of them by 4, divide by 4, divide by 4. That gets rid of 4 and 4, leaving you with n is equal to 5 in one case, and n is equal to, we can reduce, we can divide both the top and bottom by 2, divide the top and bottom by positive 2, and you get negative 3 over 2. It's going to be negative 3 over 2. For our final answers, 5 and negative 3 halves. Let's check. 5 and negative 3 halves. 5 and negative 3 halves is indeed correct. We got the correct answer, and I can highlight this one in green. That concludes homework 1-5 for Algebra 2. Thank you for watching.